Good morning, students. Today we are going to discuss the topic primitives for distributed communication in the course Distributed Systems. The subject code is CS8603. It comes under Unit 1. The learning objectives are to know about the basic concepts behind the primitives and to know the four models of send and receive operation. So usually in message passing model, to send a message and to receive a message, we have used two primitives. They are named as send primitive and the other one is receive primitive. The send primitive has two parameters. One is the destination address and the buffer. In that buffer only, we are storing the data which is to be sent. The another one parameter receive, it is also having two parameters. One is the source address from where we are getting the data, and again we need a buffer to store the received data. We have two ways for sending data when the send primitive is used. One is buffered, the other one is unbuffered. So what is buffered means? The user data is copied to the kernel buffer. The data later gets copied from the kernel buffer onto the network. For the receive primitive, the buffered option is usually required because we may receive the data earlier, but the receive process needs a storage to store the data. So it may be busy with some other receiver data. So we need a buffer to store the data until the receiver gets ready to store the message. The second option is unbuffered, that is the data gets copied directly from the user buffer to the network. Whereas in the first method, in between the user buffer and the network, we have a kernel buffer, but it is not in unbuffered option. You can categorize the primitives into blocking primitives, non-blocking primitives, synchronous primitive and asynchronous primitive. So the first one is blocking primitive. As the name itself implies, the primitive gets blocked. Okay, the execution of the process is blocked. That's why it's called as blocking primitive. Okay, so now we are separately seeing when the sending process must be blocked, when the receiving process must be blocked. So the sending process should be blocked until we get an acknowledgement from the receiver. The receiver process must be blocked until the expected message is arrived from the sender process. So the blocking primitive can be in a synchronous form. It should be in a synchronous communication. Okay, so that's called blocking primitive. So what is non-blocking primitive? So here you don't need to block the sending process as well as you don't need to block the receiving process. You can continue with your own execution. So this is a form of asynchronous execution. Okay, so a primitive is called as non-blocking if the control is returned back to the invoking process immediately after the invocation. Okay, for example, in send, the control is written back to the caller immediately before the message is sent out. You don't need to wait for an acknowledgement. That is the meaning. Okay. Then synchronous primitive. So a send or receive primitive can be either in synchronous manner or it can be in asynchronous manner. What is synchronous manner means? Before starting the communication, both the send and receive should be handshake with each other. Okay, only when the receiver knows the other process sending the data and we have to be ready to receive the data. Until then, the sending process must wait for the receiver. Okay, so that's why it's called as synchronous communication. So what is asynchronous? So here we don't need to wait for each other. That is the sender and receiver no need to handshake with one another. Okay, so the sender can be asynchronous. That is, it can send the data in a flowing manner. It won't need to wait for an acknowledgement. It won't need to wait for a receiver. Okay. So implementing a non-blocking operations are a tricky one. So how can you check when the process gets completed without getting an acknowledgement means for every asynchronous call, we may get a handle. So using that handle, you may figure out whether the process gets completed or it is blocked. So we have 4 modes of send operation. One is blocking asynchronous, non-blocking asynchronous, then blocking synchronous and non-blocking synchronous. So what is blocking synchronous send? That is, the send operation is both in a blocking in nature and it should be in a synchronous nature. Okay. So that is, the data gets copied from the user buffer to the kernel buffer. From the kernel buffer only it is sent over the network. After the data is copied to the receiver system buffer and you issue the receive call, we get the acknowledgement from the receiver. Then only the control is returned to sender process and it can send another one message. So what is non-blocking synchronous send? So here the data is directly copied to the user buffer to the kernel buffer. Okay, you don't need to wait for the copying time from the kernel buffer to the network. So once the data is copied from the user buffer to kernel buffer, you can return the control to the sending process. Immediately it can send another one message. Okay. So this is called non-blocking synchronous send. So the user process must keep checking for the completion of a non-blocking synchronous send. So with the help of the handle, as I told already, with the help of the handle, you have to check the completion. So what is blocking asynchronous send? So the user process that invokes the send is blocked until the data is copied from the user buffer to kernel buffer. What is non-blocking asynchronous send? So non-blocking asynchronous send. So you don't need to wait for an acknowledgement. Similarly, you don't need to handshake with the receiver. So the user process that invokes the send is blocked until the data is transferred from user buffer to the kernel buffer is initiated. Control is returned to the process as soon as this transfer is initiated. And again we get the handle. So with the help of the handle, you can know about the completion of the process. So they are the diagrams for blocking synchronous send and blocking receive. Okay, so blocking synchronous send, we have to wait for an acknowledgement. Okay. So this one is non-blocking synchronous send and non-blocking receive. That is, you don't need to wait for the acknowledgement process. But anyway, you have to handshake with the receiver. So blocking asynchronous send, and this one is non-blocking asynchronous send. So with this, we are concluding the topic primitives for distributed communication. Thank you.